Hi guys, Audrey here. In this video, we're going to try to understand a little bit better what the sequence of partial sums is telling us. So we know that the sequence of partial sums is the sequence that's made up of the finite sum. So the first term is the first term of the series. The second partial sum is the sum of the first two elements. The third partial sum is the sum of the first three elements. And we have a sequence of that, and we know that that sequence should be doing the same thing as our series. So let's do a concrete example to make this make sense. So let's consider this series n equals 1 to infinity of 1 over 2 to the power of n. Okay, so my first partial sum here, my s sub 1, will be the sum from n equals 1 to 1 of 1 over 2 to the n. Well, that's just a half. S sub 2 will be the sum n equals 1 to 2 of 1 over 2 to the n. Well, that's going to be 1/2 plus 1/4, which is equal to 3/4. S sub 3 is equal to the sum of the first three elements, 1, 2, 3, of 1 over 2 to the n. So that's a half plus a fourth plus an eighth, which is 7/8. And then S sub 4 is the sum of the first four elements, 1 to 4, of 1 over 2 to the n, which is 1/2 plus 1/4 plus 1/8 plus 1/16, which is 15 over 16. Okay, and so on and so forth forever. So now here, just to be clear, my S sub 1 is equal to 1/2, and my A sub 1 is also equal to 1/2. My S sub 2 is equal to 3/4, but my A sub 2 is just equal to that 1/4 that I added here. My S sub 3 is equal to 7 over 8, but my A sub 3 is just that 1 over 8 that I added. So notice that my S sub 3 and my A sub 3 are different things. My S sub 3 is the sum of the first three elements. My A sub 3 is just the third element. My S sub 4 is the sum of the first four elements. So that's 15 over 16. My A sub 4 is just the fourth element, so that's just 1 over 16. Now notice, if I were to do the limit as n approaches infinity of a sub n, well, that's saying the limit as n approaches infinity of 1 over 2 to the n. Well, that's 1 over infinity, which is 0. So what this is telling me is the sequence 1 over 2 to the n converges to 0. But it's also telling me that the test for divergence fails for the sum of 1 over 2 to the n equals 1 to infinity. So if the test for divergence fails, that means we have to do something else. So now we're looking at these partial sums, so we can create our sequence of partial sums. The sequence of partial sums here is S sub n, and that S sub n is the sequence 1/2, 3/4, 7/8, 15 over 16, and so on and so forth forever. So what does it look like is happening to the sequence? In other words, if I evaluate the limit as n approaches infinity of S sub n, what's happening to the values here? Well, we have 1/2, then 3/4, then 7/8, then 15/16. It looks like these values are getting closer and closer and closer to 1. So right now we're just going to say that this is equal to 1, even though we don't actually have the general term. We can sort of tell just by looking at the values, they really look like they're getting close to 1. So the fact that this limited and goes to infinity of S sub n is equal to 1, which is different than my A sub n, which went to 0, tells me that therefore my series n equals 1 to infinity of A sub n, which is sum n equals 1 to infinity of 1 over 2 to the n, converges to 1. Okay, so that wasn't very rigorous though, because we just kind of looked at the values and we're like, hey, look, it looks like they're going to 1. So first we're going to look at some things where we actually have the general term of the sequence of partial sums, and then we're going to talk about how it's actually sometimes really hard to find the general term of the sequence of partial sums. Now that we understand though, let's just do a couple examples here. So let's say that I am given the general term of my sequence of partial sums. So we're going to let S sub n equal negative 1 to the power of n, e to the n plus 8, be the nth partial sum, i.e. the general term of the sequence of partial sums of some series where we don't know our a sub n equals 1 to infinity of a sub n. Now the first thing that we want to do is find a sub 1 and a sub 2. Well, I know that S sub 1 is equal to the sum of n equals 1 to 1 of a sub n, which is just a sub 1. So kind of like we saw up there a second ago with that concrete example, we know that S sub 1 is equal to a sub 1. So if I can find S sub 1, then I have found a sub 1. And we can find S sub 1 by plugging in. So negative 1 to the 1, e to the 1 plus 8. So that's just 8 minus e. So since S sub 1 is equal to 8 minus e, a sub 1 is also equal to 8 minus e. Now to find a sub 2, well, I know that S sub 2 is equal to the sum n equals 1 to 2 of a sub n, which is a1 plus a2. So in other words, a sub 2 is equal to S sub 2 minus S sub 1. Well, I already have S sub 1, so let's calculate S sub 2. S sub 2 is equal to negative 1 squared, e squared plus 8, so that's actually 8 plus e squared. So a sub 2 is 8 plus e squared minus 8 minus e. Those 8's cancel out, and I actually end up with a sub 2 is equal to e squared plus e. So this actually gives us an important result here. If I want to find a sub n is equal to S sub n minus S sub n minus 1. So if I want a sub 8, I can do S sub 8 minus S sub 7. Now, for part B here, we are going to determine whether or not a sub n converges or diverges. And by a sub n, I don't mean the sequence, I mean the series. So the sum n equals 1 to infinity of a sub n, does it converge or diverge? So I can do here the limit as n approaches infinity of S sub n, because remember that gives me information about what's happening with the series. So my S sub n is negative 1 to the n times e to the n plus 8. So that's the limit as n goes to infinity of negative 1 to the n times e to the n plus 8. Well, this doesn't exist because we're going to have that e to the infinity. So that's infinity. So this is like negative 1 to the infinity, e to the infinity plus 8. That's negative 1 to the infinity times infinity plus 8. Well, that 8 just kind of gets absorbed into the infinity. It doesn't matter. But that negative 1 to the infinity, if we are at an even number, it's positive. And if we are in an odd number, it's negative. So we kind of have this oscillating thing happening. We have this bouncing back and forth happening. So we're like bouncing back and forth between positive and negative infinity. So this limit does not exist, which implies that therefore the sum in equals 1 to infinity of a sub n diverges, because s sub n also diverges. So s sub n diverges. Okay, let's just do one more example here. So let's say that s sub n is equal to 2n plus 4 over 2n minus 3 is the sequence of partial sums. So the nth partial sum of the sum in equals 1 to infinity of a sub n. So here we're going to ask some different questions. The first question is just, does this series converge or diverge? So again, we can just look at our limit of partial sums, our limit of our sequence of partial sums, limit as n goes to infinity of s sub n, that's the limit, as n goes to infinity of 2n plus 4 over 2n minus 3. I can take my dominant terms, take the big stuff, and see that this is equal to 1. So s sub n converges to 1, which tells me that therefore the sum in equals 1 to infinity of a sub n also converges to 1, because the sequence of partial sums and the series are doing the same thing. Okay, B. Now that I know that, can I say what the limit as n goes to infinity of a sub n is? Can you evaluate the limit as n goes to infinity of a sub n? And the answer here is actually yes. By the test for divergence, the limit as n goes to infinity of a sub n must equal 0. Because the test for divergence tells me that if it doesn't equal 0, it diverges. So the fact that this converges tells me that that limit must equal 0. Up here where it diverged, I couldn't actually say anything. Diverges means it could be 0, it could be not 0. But converges means hands down that limit was equal to 0. So this is equal to 0 by the test for divergence. All right, that's all. The next question that we want to answer is, what about series that we know? We've talked about geometric sequences. Let's learn a little bit about geometric series by thinking about partial sums, and we'll do that in the next video. Bye, guys.